Please close this.
Hello?
Yep. Hi all. Good evening to all. So my name is Prakash. So I'm the math tutor for this webinar. So today we are going to discuss about the integers. So before that, let me put some points here. So you can just unmute your mic if you want to talk to me, or if you have any questions in between the class, just go ahead and unmute and you can talk to me. You can ask me the questions if you have any. Or else you can also ask me the questions on the chat. I mean, in the later, I mean, at the end of the class, we'll do the questions as well. So in between, if you have any doubts, feel free to ask. Yeah, hope everyone can hear me. So how the webinar goes? So using the whiteboard and the presentation, I mean the notes which I have prepared. So using those two, so I'm going to teach. Okay. Yeah, let me. Yeah, hope everyone can see this thing. So today we are going to discuss about integers. What is integers and what are the properties of integers and how to add, subtract, I mean all arithmetic operations such as addition, subtraction, multiplication and division. Like comparing the numbers and how to represent it in using number line and all these things. Okay, so let's start with the basics. What is integer? Integer is nothing. Hello. Yeah. So it's a part of a number, part of a rational number, or a type of positive, can be negative, and also zero. That's what integer says. So just take a look at this. So numbers can be positive. So integers means we have a positive integers, negative integers. Okay. And
Sir?
how do we represent? Yeah.
Your voice is breaking.
Can you hear me now?
Yeah.
Everyone, is it okay now?
No, it's still breaking.
Still breaking. Just a moment. How about now? Is it okay now?
Yes, it is.
Yeah. Okay. Great. Okay. So I think these are, I mean, integers is nothing but it's a part of rational numbers. Integers can be negative, positive, and zero. You can see that the positive integers are always greater than zero, as we all know. The negative integers less than zero, which is lesser than zero, and it goes up to negative infinity. And zero is also an integer. So 0 is non-negative, or it is not a positive or a negative. We can call it as a 0 as a 0. Okay, so now what are the types of integers? So in integers we have a three types, or rather we can represent integers in three ways. One is positive, one is negative, and one is zero, as we discussed. And now how to compare, how to represent these numbers, these integers using a number line. As you see the number line here, so it starts from -10 to 10 here, but it's not starts from -10. Generally, it starts with a negative infinity. That's the smallest number. So it goes up to positive infinity. Okay. Now, let's go to the comparison of numbers. So how do we compare the numbers? So generally, we will compare the number using the greater than sign or less than sign, or even greater than or equals to sign, right? So here, so generally the negative numbers are the smaller numbers, the positive numbers are the bigger numbers. So once it goes this side of a number line, I mean this side, the negative side of a number line, which is nothing but a negative numbers. Those are negative numbers, and it goes on. Once it goes, so for example, if you compare -2 and -7, -7 is the smaller number because -7 is placed left side of -2. So that's why -7 is a smaller number. So this is how we can compare these numbers. Okay, so we can, in the right side, in the greater sign, if you take any two numbers, 6 is greater than 2 because 6 is placed right side of 2. So that's how we generally compare the numbers using the number line. But even in general case, we have to just assume if we are the starters, okay, if it is confusing, we just need to compare using the number line, and we need to check whether which one is greater or which one is lesser. Okay, this is about the comparing the numbers. As you read the definition here, the number on the left is less than less than a number to the right. So that's what we just discussed. Similarly, the number on the right is greater than the number to the left. So that's what we just compared. So these are the examples. Okay, so we'll do more on this. Let's go to the next one. Yeah. Okay, so before going to the addition and the subtractions, let's go to the whiteboard. So let me draw the number line. So in this number line, so how do we compare the numbers? 0, -1, -2, oh. So let's say 1, 2, 3. And this is a negative side. And you might have a question that why the left side numbers are negative and the right side numbers are positive. Is it the same always? So generally in maths or a general day-to-day life, yes. So generally the left side indicates the negative number, the right side, it is nothing but a positive number. So you can call it as an increasing. See here, the numbers are increasing. So here the numbers are decreasing. So which means what? So decreasing means the value is getting lower and lower. Increasing means the value is getting higher and higher. So that's why. So we'll put it in that way. The left side of 0 and the right side of 0. So this is increasing the numbers. So here the numbers are decreasing. Okay. So this is a basic example I can give. Okay. So let's compare two numbers. So so how so I hope everyone knows this is a less than symbol. This is a greater than symbol. So minus 1, 2, how do we compare? So we can put it in this way, because minus 1 is smaller than 2. We can also write the same thing as this. So which is the same. I mean, so this is called as minus 1 is less than 2. Here, the 2 is greater than minus 1. Both are same. But you can see the signs are changed, but which means the same question or comparing the same numbers, we can represent that in a two different ways. So let's take another example. Let's say 3 and minus 2. 3 and minus 2. So obviously we're going to put a greater than sign here. 3 is greater than minus 2. So we can also write this as minus 2 is less than 3. Both are same. So you might get a question, so what is the other way of, is there any other way of representing or comparing these numbers, okay? So what is the other way of comparing this? So we can also compare, or we can also represent this as like this. So these are the comparing the numbers. Okay, let's go to the basic arithmetic operations such as addition and subtractions. So how that works? So I hope everyone knows. Hope everyone in a 7th class or plus. So I hope everyone know that what is addition of a negative numbers if we have. So for example, if we have two same signs, so either it is a positive, both the numbers are positive, or both the numbers are negative. In this case, if we are adding these two numbers, we'll get we have to add both the numbers, and we have to put the sign based on the question. For example, in the first question, you can see that plus 5 plus 4, both are positive numbers, so the answer is positive. In the second one, both are negative. See, minus 7, but we are adding both the negative numbers. Okay, so we are going to add, obviously, which is 7 plus 5 is 12. Since we have both negative numbers, we're going to put a negative sign in front of that. So this is about addition of the same signs. Let's go to the whiteboard. Just a moment. Yeah. So addition. So addition of same numbers in a sense what? Same signs in a sense. 2 plus 3. So both are same signs, we can just add directly. So if both are negative signs, minus 3 plus minus 5. See, here both the numbers are negative. So obviously we are going to add, which is 8. Since both the numbers has a negative sign, we are going to put as a negative. So this is for addition. What if we have one positive number and one negative number? Let's take an example as 3 minus 2. You can see that here we are subtracting, obviously everyone knows. Okay, let me take in this way. 3 plus of minus 2. See, here one is positive number, one is negative number. So which means we have to subtract. If both the signs are same, then we add. If one sign is different compared to the other one, we are going to subtract. So 3 minus 2, which is 1. Similarly, minus 5 plus 3. You can see that the same thing. Okay, let me take a different number here. Yeah, minus 5 plus 9. You can see that minus 5 is a negative number, 9 is a positive number. So we'll get we have to subtract, obviously, right? So 9 minus 5, which is 4. So this is about the addition. So how the subtraction varies to the addition? Let's go to the notes. See, in subtractions, all rules are similar, but if you read the definition there, if you are subtracting the two positive numbers, it's a straightforward one. We just need to subtract. what if we have a negative signs? So let me explain that now. Okay. So in subtractions, what if we have a same signs? See, 4 is a positive number, 2 is a positive number. So if we are subtracting, the same sign numbers, both are positive, it's straightforward. We are just going to subtract. How? 4 minus 2 is what? Just 2. If we have the same signs but negative signs, if both the numbers are negative while subtracting, what we need to do? So this is an interesting question. You can see that minus 4, since we are already subtracting here, so this becomes an addition. So just try to change this as an addition. Okay, let me explain the previous question. So can we write this as 4 plus of minus 2 using addition? We can write it, right? See, minus of 2 in a bracket, so which is nothing but a 2. Similarly, this question, we can write this as, using addition, how can we write this? Minus 4 plus minus of minus 2 becomes plus 2. So this is how we can write. So which is nothing but a minus 2. Why minus 2? Because the greater number, here the bigger number, don't compare with the signs, just think 4 and 2. 4 is a bigger number. So in front of a 4, we have a negative sign. So that's why we will get the answer as minus 2. Let's try a few more. 4 minus 3. It's just a 1. So what if we have a smaller number here? For example, 4 minus 9. Just go ahead and subtract, which is 5. Since 9 is a bigger than 4, we are going to put negative in front of that. So in this case, how about this one? Minus 3 minus 5. One negative number, one positive number. So just turn this into your addition, how it works. Minus 3 plus of minus 5. So here it is nothing but adding to two negative numbers. So we'll get minus 8. I hope everyone learned these basics. So I'm going to stop these addition and subtraction here. If you have any questions, we'll discuss later. Okay, the next thing, the multiplication and division. So the multiplication, division, we have a basic rules of signs. If we are multiplying or dividing the two positive numbers, answer is positive. Let me write those rules. Yeah, you can see that, I hope. So if we are multiplying or dividing the two positive numbers, we'll get the answer in positive. If both the numbers are negative, again we'll get the answer in positive, because minus of minus, minus times minus, or minus divided by minus becomes a plus. So if one number is positive, other one is negative, in that case we'll get the answer in negative. Okay, let's try some questions. Multiplication. 4 times 9. So we don't have any signs here. Both are positive numbers. So straightforward. 4 nines are how much? Which is 36, which is nothing but a plus 36. What if we have a negative numbers? Minus 3 times minus 7. You can see both are negative numbers. If you multiply, we'll get 21, because minus of minus becomes plus. So plus 21, because both the numbers are negative here. Okay, what about the third type? For example, 1 is a negative number, the other one is positive number. You can see that one is negative, one is positive. So we are going to multiply 6 4 24. So since only one number is negative here, we are going to put a negative sign. So similarly, 9 times minus 3 is 9 3s are 27. Since we have only number as a negative, so positive times negative becomes a negative. You might have a question: what if we have a more than two numbers multiplication? For example, 3 times minus 5 times a 7. So how to solve this? So first we are going to solve these two. What is 3 times 5, which is 15. 3 times minus 5 is minus 15. Minus 15 times 7. What is minus 15 times 7? Here one is positive number, other one is negative number. So what is 15 times 7? 15 times 7 is 105. So minus 15 times 5 is minus 105. So let's take 4 numbers, how the 4 numbers works. 3 times minus 3 times 7 times minus 4. In this case, how this works? So again, since it's a multiplication, hope everyone, hope you guys know that the board mass rules. So board mass rules no need to use board mass rules here. The reason is all a multiplication, right? So we can just go ahead and multiply. What is 3 times minus 3? 3 times minus 3 is 3 3s are 9, so minus 9. And what is 4? 7 4s are 7 times minus 4 is minus 28. So now we have got two negative numbers which we are going to multiply. What is 9 times? Minus 9 times minus 28. So both are negative number. If you multiply, we'll get the answer as positive. So 9 times 28 is 250. So this is how it works. Similarly, the division, the same as division. I'm talking about a signs. So let's take the question in division. Minus 40 over 5. So let me write this way. So which is nothing but we are dividing minus 40 by 5. You can see that minus 40 is a negative number, 5 is a positive number. So we'll get the answer in negative. So 5 8s are 40. So minus 8 is our answer. Let's take one more. Minus 27 over minus 3. In this case, you can see that we have a two negative number. Both minus 27 and minus 3 are negative. So if we are dividing a negative numbers, both negative numbers means minus minus cancels out, which is nothing but minus divided by minus is plus. So plus 27 divided by 3 is 9. So plus 9, or else you can just simply write 9. You can take more example. For example, minus 36 over, let's take plus 36. So plus 36 over minus 9. So how this works? 36 is a positive number, minus 9 is a negative number. So one positive number, one negative number. So how this works? So answer obviously in a negative. So 9 4s are 36. So we already know if both are positive, it's a straightforward. You can see that both are positive. You can just divide. So this is how the division and multiplication works. Hope it clears to everyone. So if you have any questions, we'll discuss. Now, the representation of a number line. Yeah. So we learned how to add and subtract, right? How to add, subtract, multiply, and division of a numbers or integers. So how to add and subtract using the number line? Let me show you that. So how to add or subtract the numbers using the number line. So let me draw a number line first. Yeah. So let's say the question is what is 2 plus 4? Yeah. What is 2 plus 4? Okay. So I think we don't have a 4. Let's take okay, let's take 2 plus 4. So 2 plus 4 in a sense, 2, this is a 2. We are going to add 4 numbers to 2, which means we are adding, so obviously it comes in the right side. So 1, 1, 2, 3, 4. If we extend this, so this is a 5, this is a 6. So 2 plus 4. So see, we are adding 4 here in between 1, 2, 3, 4. So 2 plus 4 is nothing but the answer is 6. Okay. So similarly, let's take one more example here. What is minus 3, or rather, yeah, minus 3 plus 2? What is minus 3 plus 2? What is minus 3 plus 2? You might have an answer in your mind. Let's try. See, this is a minus. This is a minus 3, right? Plus 2. Plus 2 means it's
Minus
it
5?
obvious.
Is it
Yeah.
minus 5?
It is not minus 5.
Minus 1.
Yeah, so let's try how. Why minus 1? You might have a question, why? See, we are adding 2 to minus 3. Adding means it comes obviously the right side, right? So adding to 1, this is a 2. So this is the answer. This portion is the answer. So minus 3 add 2 is nothing but minus 1. Okay, so let me share that the PPT. So just take a look at this. Using a number line, how to add. Here the addition is 5 plus 3. 5 plus 3. Plus means it's in the right side.
Sir,
Yeah.
I didn't really understand. How is it minus 1?
Okay, I will explain. I will explain that. Okay. So just before that, just take a look at the positive numbers. Okay. So then I will explain the negative numbers. So in this slide, you can see just positive numbers. 5 plus 3. So as everyone knows, 5 is a positive number. So here is a 5. Plus 3 means we are adding. So goes right side, right? So just add 3 times. See this 1, this 2, this 3. You can see that, this 3. So the answer is 8. So addition means we just need to go the right side. We just need to go right side. And if you see subtract, if you're coming towards the negative side. For example, what is the question that? Yeah, 6 minus 1. So you start with 6. 6 is the starting number. 6 is the initial number. Okay, 6 minus 5. So you are coming the left side. So 5 times. See 1, 2, 3, 4, 5. So what is that number? That is the answer. 6 minus 5 is positive 1. So this is nothing but, this is adding or subtracting the numbers using number line. Okay, just a moment. Just a moment. Yeah. So I will explain your question now. So here it is. So let's quickly write this. Okay, 1, 0. -1, -2, -3, -4. So what is the question? So I think we have taken as the question is 2. Let's take any question. Okay, 2. I need to check the question. 5 minus.
The question was -3 plus 2.
Okay, -3 plus 2. Okay, -3 plus 2. So the starting number is -3. So we'll start with -3, isn't it? So plus 2 in a sense what? We are adding. So we are adding 2 to that. So adding in a sense what? We are going right side, towards right side. So 1, 2. Okay. So this is the answer. That's it. See, we are adding 2 here, 1, 2. So that's the answer. Whatever the value we'll get after 2, after moving 2 digits right side, so that will be the answer. Okay, let's try one more and try. So let's tell me the question is a minus 4 plus 5. Let's try this. So where we need to start? We need to start with -4, right? So -4 is the starting number. So -4 plus 5 in essence what? We are adding 5. So 1, 2, 3, 4, 5. So we added 5. I hope you can see that. So this is a plus 5. So -4 plus 5, what is the answer? We got the answer is 1. So the answer is 1. Okay, so let's try some subtraction questions. Let me draw one more number line. Yeah. Here is 0. One moment, let me draw the number line again. Yeah. So just tell me the question as you wish, as your wish. Let's take a question as 4 minus, okay, 2 minus of -3. What does it mean? 2 minus of -3. So let's solve this question using the number line. So our starting number is 2 minus in a sense it's a left side, but we have one more minus, right? So 2 minus of -3 is nothing but 2 plus 3. Hope everyone agrees to this. So 2 plus 3 in a sense what? Right side, because we have a plus 3 here. So 1, 2, 3. We got the answer. We got the answer as 5. Even if we solve this, we'll get 5. Let's try one more question. The fourth one. Okay, just a moment. So let's take 1 minus 5. So everyone, I hope everyone knows the answer. What is 1 minus 5? Let's see how it works in. Yeah, let's see how it works in number line. Just a moment. So what is the starting? The starting number is 1 minus 5, which means what? We are going to subtract, right? So left side, we are going to go with the left side. 1, 2, 3, 4, 5. You can see that. Minus 5. So 1 minus 5 is nothing but -4. So we got the answer. So this is how we need to add or subtract the numbers using the number line. Hope I answered your question though. Okay, you can just take a look at this again. So addition is nothing but going the right side, which means it is increasing. Subtracting the coming towards left side, which is minus infinity. Okay, and how to add or subtract using the negative numbers? You can see that minus 3 plus 2 here, minus 3 plus 2. So the same example I think we did, minus 3 plus 2. Because minus 3 is the initial number, we just need to add, in a sense, right side. So we added 2, we'll get the answer as minus 1. So minus 3 minus 2, what will happen? Minus 2, in a sense, we are going to subtract. So left side. So minus 3 and 2 left side. I mean, 2 positions towards left side, which means we'll get the answer as minus 5. We got the same. So that's it of adding and subtracting the numbers using a number line. So this is how. So if an addition, go towards positive. If it is a subtraction, go towards a negative, which is nothing but left-hand side. If it is a negative, left side of a column. Okay, if you want to try one more questions, we'll do, or else we'll do later. Anyone interested to solve this question again? You want me to show again? Anyone?
Sir, it's okay.
Yeah. Okay then. So let's move to the next part of the webinar, which is the properties of. We can call the properties of integers or else properties of numbers. Yeah, the properties of numbers would be good. So because it works for all the numbers, not only integers. That's why. So what are the you might get a question as a properties of integers as well. Okay, so the answer is same. Okay, so the properties of numbers are properties of integers. You can, the question might be in 2 different ways. The answer is same. Okay. What are the properties of numbers we have? We have 5 important properties of numbers. So let's try what are they. So one is closure property, the associative property, the commutative property, then the distribution or distributive, finally identity. So I will explain what exactly each one means. Okay. So what is closure? Let's start with the closure. So closure property is nothing but if we take any 2 numbers, any 2 integers or a numbers, if we do the calculation, either it's addition or a subtraction or a multiplication, even in the division, the answer has to be the integer or a rational number, you can call it as. Okay, just a moment. Let's go to the whiteboard. Yeah. So the first one is closure property. For example, just take a 2 numbers as you wish. As your wish. Tell me 2 numbers. So let's take 5 and 9. Okay. So use these 2 numbers and try to complete all the arithmetic operations. Okay. So which is 5 plus 9. Everyone knows that. What is 5 plus 9? Which is 14. What is 5 minus 9? Which is, what is that? Okay, which is 4, right? Yeah. Minus 4. Okay. Then 5 times 9. What is 5 times 9? 45. So 5 divided by 9. 5 divided by 9 is 5 divided by, we can't simplify that. So which means what? See, in these things we have got the integer as an answer or a rational number, you can call it as. So yeah, 5 by 9 is a rational number, but it is not an integer, right? So which means, I hope you understand, closure property says that it applies only for addition, subtraction and multiplication. It won't work for a division. So this is a one case. Some of the times we won't get the answer as a integers. And the other case, for example, if you take a 0 times, 0 comma 5, the 2 numbers, just do the same logic. 0 plus 5 Or you can take 5 plus 0, both works anyway. So 5 plus 0, 5 minus 0, 5 times 0, 5 divided by 0. Okay, 5 times 0 is 0. See, in the first three positions, addition, subtraction, and multiplication, we got the answers as integers. 5 is an integer, 0 is also an integer. But in the last case, as you see, 5 by 0 is nothing but what? Infinity. So it's not an integer. So this closure property won't work for division. So let me give the definition to you. Just a moment. Yeah, just take a look at this definition. Okay, closure property for any two rational numbers. So these rational numbers you can just consider as a integers. So for any two integers, if we do the addition, subtraction, or a multiplication operation, which gives a integers again, so which give the output is integers. Okay, so this works only for addition, subtraction, and multiplication, right? That's why this closure property says that it just take a couple of numbers and do the basic arithmetic operations, and the output has to be the integers. Okay, that's it. Yeah, the second one is the commutative property. What do you mean by this property, the commutative property? So in commutative, we have two types. One is for addition, other one is for subtraction. So let me type that. Just a moment. Yeah, here it is. So the commutative property is nothing but if we interchange. What do you mean by interchange? Interchange is nothing but changing the position of the, changing the position of the place or something. So for example, a plus b can be written as b plus a, right? Because we'll get the same answer. So if we look at, let's take an example, 5 plus 9 can be written as 9 plus 5. See, we have changed the position, or else we interchange the value position of the values, digits, but we'll ended up getting the same answer. Okay, so that's the commutative property. The commutative property for addition. So addition in a sense, just this, a plus b equals to b plus a. So we are just interchanging the position of the values. Still we'll ended up getting the same answer. Let's try multiplication. Let's take the same a-b case. A times b equals to b times a. Let's try one example. 3 times 4 is same as 4 times 3, right? 3 4s are 12, 4 3s also 12. So it works for multiplication as well. So what is the commutative property for addition? What is the rule for the commutative for the addition? You need to write this, okay? A plus b equals to b plus a. Commutative property for multiplication, this rule. A times b equals to b times a. Okay, you might have a question. Is it work for subtraction or a division? Want to give it a try? Just try it. So let's take the couple of numbers, same numbers, 5 plus 9. 5 comma 9 rather. So 5 comma 9 works for addition and multiplication. So let's try for subtraction. What is 5 minus 9? Is it equals to 9 minus 5? It won't, right? Because 5 minus 9 is minus 4 is not equals to 4. The output is not same. If we interchange the position of the values, output won't be the same. So this commutative property won't work for subtraction. So similarly, if you want to try for division, 5 by 9 is not equals to 9 by 5. Am I correct? So it won't work for division as well. So we have a commutative property for only addition and addition and multiplication. Addition, a plus b equals to b plus a. Multiplication, a times b equals to b times a. Hope everyone understand this. Yeah, let's go to this, just a moment. Yeah, here it is. Just take a look at the definition again. The commutative property says we can swap the numbers over, which is nothing but we can interchange the numbers position. Still we'll ended up getting the same answer. So it works only for addition and multiplication. I hope both the properties, hope you guys understand both the properties. So what's the third one? Third one is associate property. It's a simple one. What is associate? Hope you guys know, as I said, the Board-Morse rule. Just change the position of the brackets, parentheses, and see if it works. So let's try some question. So the third one is, yeah, just a moment. So here is the third one. The third one is associate. So associate property again works for addition and multiplication. So how it works in addition? For example, if we are adding the three numbers. So how do you add three numbers? Are you going to add, is it possible to add three numbers at a time? Yes, but how we add? For example, 6 plus 5 plus 2. How we add? We are going to add 6 plus 5, 11, plus 3, plus 2, which is 13. So this is one way. So what is the other way of adding? 6, 5, 2. 2 plus 5 is 7. What is 7 plus 6? So this is the other way of work. So we have only two ways, right? As you see, either you can go with the first two numbers and then the second number, the third number, or else the last two numbers and the next number. So similarly, this associative property says that if you can add in this way or else b plus c. So that's the only thing. So still we ended up getting the same answer, obviously. So let's try one example. Let's take ABC as 492. 4 plus 9 plus 2. Hope everyone knows the answer. So let's try in both the ways. So we are just doing it in a different way. You can see that. Either we are going to do 4 plus 9 first or else 9 plus 2 first. 4 plus 9 is 13. 13 plus 2 is 15. So in this case, 4 plus 9 plus 2 is already 11. So what is 11 plus 4? Oh, wait. Oh, yeah, 11 plus 4 is 15 and 13 plus 2 is also 15.
Sir?
So yeah.
Why can't we plus 2 plus 4?
Why can't?
Why can't we plus like 2 plus 4? Like you, for example, like you put, we can plus 4 plus 9 and 9 plus 2, but why can't we plus 2 plus 4?
Yeah, that's a good question. That's a good question. Yes, we can do that. But okay, let's say you're adding 6 numbers at a time. Are you going to add this and this first? Yeah, it works, right? It works. Obviously, I do agree. Everyone agrees that it works. But generally speaking, we'll start with this two and then this, then this, then this. We'll go from bottom to top or a top to bottom, isn't it? So if we interchange the numbers, yes, it is easy to solve. We have only 3 numbers. What if we have a more than 3 numbers? For example, 5 set of numbers. So in the coming years, you might need to find the average of 5 quantities. Okay. So you might need to find the average of 5 quantities like this. Are you going to add this one and this one first and then this one and this one second? Yes, it works. I do agree it works. But generally speaking, so we'll go with this one and this one, and then we'll do this. So that's how it goes, right? So that's why it is. So
Okay,
if you want to write it in this form, I am fine. If you want to write in this way, it is fine. If you want to write in this form, yeah, it works. If we have a 3 numbers, it's okay. It's easy to solve. So it's okay to go with A plus C first. But generally speaking, so it might confuse us, right? At one point, if we have more than 5 numbers or something. So in that case, that's why we'll start with this. So, but we can write this as A plus C plus B as well. Hope I answered your question though. Yeah.
thank you.
Yeah, yeah. You're welcome. Yeah. So this is addition. So associative property of addition is nothing but this one. So what about multiplication? The same thing. We're just interrelating. So let's take A times B times C equals to A times B times C. So how do you multiply 3 numbers at a time? I think we tried once, right? Let me go to that page. Yeah, here I think. Yeah, here you can see that we tried the multiplication of 3 numbers or 4 numbers. How we did? We multiply. Let me take the different color. If we multiplied these 2 numbers first, and then we multiplied the answer with the third number, the similar thing. So that is nothing but a associative property for multiplication. So without knowing itself, I mean, we tried, right? We haven't realized that we use the associative property here. So that's the basic thing. Okay. So that's, I hope, yeah. So this one. So A times B you can do first, or else B times C. And as you asked, we can do A times C as well. But generally speaking, we'll go with this. So let's take some example. 2, 3, 4. So 2 times 3 times 4. So we ended up getting the same answer. If you want to check, just try. So 2 3s are 6 times 4, which is 24, and 2 times 12, which is 24. We'll get the same answer. You can see that. So in multiplication, it even difficult, right? Multiplying the other numbers like A and C and then B. If you have more than 4 5 numbers. So that's why let's go with the ascending order or a descending order, or going up or down. It works. But multiplying interchanging, yes, it works. But sometimes we lose something, or we might ended up getting a wrong answer if we do wrong calculation in that case. So this is about the associative property. This works only for addition and multiplication. It won't work for subtraction. You want to try why it won't work? If you take the same example, 2 plus 3, or rather 2 minus 3 minus 4, is it same? Yeah, it is same. What if we have, yeah, just try this. Just a moment, let's go to the next page. So 2 minus 3 minus 4 equals to 2 minus 3 minus 4. Is it same? Just try. It is minus 1 minus 4. This one is 2. What is this? Minus 1. We got minus 5 here. Yeah. In this case, we got 2 plus 1, which is 3. You can see that both are not equal. So that's why this associative property won't work for a subtraction and even division. If you have 3 numbers, just think of for 2 numbers also it won't work. So how it works for 3 numbers? I mean in division. So that's it of associative property. The next one is an important one, which is distributive property. So you might know what is distributive. Distributive is, in a sense, it's just a distributing or a foiling the terms. Let me explain what exactly it is. Yeah, quickly. What is distributive property? We are just distributing the things. Okay, let me tell you how it works. So let me think of a real-time example if I have. See, this is the distributive property. A is outside the bracket, you can see, and B plus C. So if we distribute this, A is multiplied with B as well as C. So A times B plus A times C. So you can put the subtraction here as well. So B minus C. So A times B minus A times C. Yeah. So this is about the distribution. So not only two numbers, you can do the distribution for n numbers. It can be any, it can be 2, it can be 3, it can be 4 as well. So you just do, oh, need to change the numbers, right? Just B plus C plus D. So A times B plus A times C plus A times D. So you can have one negative and a positive number if you want to. For example, in this case, A times B is AB, A times C is AC, A times D minus D is minus AD. That's it. Why distributive property? You might have a question, why we need this? So this distributive property, we are going to use this distributive property in algebra more often. Okay, so let's try why this. So 102 times 5. So how do you solve this question? So generally you're going to multiply, right? So can we split this 100 as 100 plus 2 times 5? So you're going to distribute 5 now. 5 times 2, 5 times 100. What is 5 times 100? 500. What is 5 times 2? 10. So we got the answer. So we haven't multiplied here. We just distributed. We just used the distributed rule. So we got the answer. If you multiply these two, we'll get the same answer though. So that's what the distributive property means. We can split into 2 numbers, 3 numbers as you wish. So we are just making the question simple. For example, 96 times 4. So it will take some time to solve this question, right? So can we split 96 as 100 minus 4? We can. Times 4. And then you're going to distribute. What is 4 times 100? What is 4 times 100? 400. Minus, what is 4 times 4? 16. Just 16 take away 400. We got the answer. 384. See how easily we got the answer.
Sir?
Yeah.
Sir, can you do like 90 plus 6 into 4?
90 plus 6. Okay, your question. Yeah, so it's up to us. Okay, so whichever easier, we can just do that. Whichever is easy. For example, you ask that question. Let me give an example of an 84 times 4 times 5. Okay, or 5 times 84. Okay, so this is the question. So how do you do this? You can split 84 as 100 minus 16 if you want. So if you felt multiplying 5 and 16, 5 times 16 is difficult, you can also solve this as 5 times 80 plus 4. Okay, 5 8s are how much? 400. 5 8s are 40, so 400. So 5 4s are
20.
20. So we got the answer is 420. So
Okay,
even
sir.
say in this case, we'll get 500. 5 16s are it might take some time to calculate 16 and 5, right? So which is 80. So we'll get, or else if you want to do in different way, you can do this. 8 times 84, 5 times 84. Can you split this as 100 minus 10 minus 6? Can we do that? So
Yep.
yeah, 500 minus 50 minus 30. So you got it. Take away 50 of 500, we'll get 450. Take away 30, we'll get 420. Make sense? I hope so.
Yes, sir.
Yeah, great. So this is about the distribution. So let's try the last one, which is identity. What is identity? So identity property is nothing but if you are multiplying, or okay, let's go with the addition first. What is addition? For example, we have a number. We are going to add 1 to that, which is same as 1 plus x. So this property we hardly use though. Identity is nothing but a 1 generally. Identity, this identity property, even in matrices you're going to learn. So this is how it works. One value, x is a value. If you want to take a instead of x, it's fine. A plus 1 is same as 1 plus a. It's kind of a commutative property, but this is how it works. So similarly, the multiplication, if you multiply a times 1 equals to 1 times a. So a times equals to 1 times. Okay, how to write this? So we can write this as a. So similarly, a times 0, which is same as 0 times a, which is 0. So that's it. Let me show you the definition of these two. Just take a look at this. So distributive property we already learned, right? It's just distributing, which is nothing but a foil the terms. Okay, so just go through all these things. You can see that the closure property won't work for division. The closure property won't work for division. The commutative property only works for addition and multiplication. Okay.
Sir?
Yeah.
So I didn't understand the identity.
Okay, so I will explain that. Okay. So
Okay,
closure won't work for division. Commutative property won't work for subtraction and division. You can see that, even associative. So distributive property is not applicable for multiplication, right? So distributing is nothing but we are just distributing the terms. Yeah, just take a look at this. So identity property. So just read the definition and see if you understand anything. Like I will explain.
Sir,
Yeah.
what does the reciprocal of rational number mean?
I will explain. I will explain that. Yeah. So here I am. Just a moment. Just a moment. One moment.
Sir?
Yeah, one moment. I was not able to go to the whiteboard. Just a moment. Yeah.
So when you multiply,
yeah.
Yes.
Yes.
So
tell me.
when you multiply another one number with another number, you should get the same product.
Where? In which one you are asking?
For identity property.
Yeah, basically yes. Okay, let me give a few examples instead. Okay, let me put it in this way, identity. So in addition, for example, if you're adding, okay, so I just made a mistake there. It's not 1. So if you are adding 0 to the number, we'll get the answer as same. Okay, so that's identity. In multiplication, if you are multiplying with 1, we'll get the same answer. So that's the identity. Identity is nothing but the same number. We'll get the answer as the same. Okay. So in addition, to get the same number as actual, we have to add 0. In multiplication, we need to multiply by 1. Am I clear?
Yes, sir.
Okay. So the final part of the webinar is reciprocal. What do you mean by a reciprocal? Reciprocal, in a sense, it's just an inverse. Rather, we can say a swap the fraction. Swapping the fractions. Okay, turning the fractions. Okay, let's try one question. What is the reciprocal of 2? The reciprocal of 2 is 1 by 2. Okay, the reciprocal of -3 is -1 by 3. So reciprocal of a fraction, for example, what is reciprocal of 5 by 2? It is 2 by 5. So that's what the reciprocal means. Reciprocal, in a sense, 1 divided by the original number. Or else you can also say that swapping the fraction. So denominator becomes the numerator, numerator becomes the denominator. So that's of the reciprocal. Let me add the, yeah, just a moment. I think this one, right? You can see that. Okay, so here I haven't explained much though. So what does it mean? What if, see, a by b is the original number. So let's take 5 by 2 is the original number. What is the reciprocal of 5 by 2? It is 2 by 5, right? So if you multiply the actual number with the reciprocal number, we'll get the answer as 1. You can see that 5 2s are 10, 10 divided by 10 cancels out, we'll get the answer as 1. So that is the reciprocal, in a sense, turning the fractions, or else it is 1 divided by a number. Reciprocal of 5 would be 1 by 5. But reciprocal of a fraction, 3 by 7 would be 7 by 3. If you are multiplying the original number with the reciprocal number, if you take this example as a 5 and 1 by 5, 5 times 1 by 5, what will happen? 5 divided by 5, we'll get the answer as 1. So that is the reciprocal of a number. So that's it, I think. Yeah. So I think we're done with the class. So please let me know if you have any queries. So we learned the basics of integers. How do we represent the number line? How do we represent the integers in number line? And then we learned how to add, subtract, multiplication, and division of integers. Then we learned how to add and subtract the integers using a number line. Finally, the properties. Just let me know if you have any questions. Just ask me in the chat, or else you can unmute and you can ask me. Feel free to ask me if you have any questions. No one has any? Okay. So let's try, if you don't have any questions, I have few questions to try. Just try those then. Okay, so this is nothing but a comparing a numbers. Can anyone tell me which sign comes here?
Sir, 8
It's like
So less than.
it's less than.
Very good. So what about the second one?
Greater than 7.
Greater than.
Are you sure?
Yes, sir.
Good. Next one.
-7 is greater.
That's greater than.
Greater than. Nice one.
Less than.
Less than.
Nice.
Greater.
Greater than.
Greater than.
Nice.
Greater than.
Less
Just
than.
add.
Less,
No.
less
Greater.
than.
So greater
okay.
than.
Okay.
Greater.
Greater than, so the side is there.
Just a moment. Yeah. So the last one is greater than, right?
Yeah.
Yeah. Where I am. Okay. So the next set, I want you to solve these questions using a number line. But I know it's difficult to try in this, but let's try at least a couple of questions using a number line. So how it works?
Sir, the first one is 20.
20. Everyone agrees to
Yes.
that? It is -9 plus 11. -9 plus 11. See, this is a -9, for example. And let's say 1, 2, 3. Anyone want to try this question? Everyone agrees to 20.
Sir, it will be 2.
Okay. See, -9 is the original number, -9. Plus 11, in a sense, we are going to move 11 units towards right? So 11. So -8, -7, it goes. So it goes up to the 11 times. So we'll get the answer is 2. So what about the second question?
So can I say the answer?
Yeah.
So it's -19.
Yeah. So because both are negative, for example, in a number line, if it is -16 and -17, -18, and then -19. So -16 is the starting number. We are subtracting 3. So towards left side, see, 3 minus 3. We got the answer is -19. Okay. Anyone? What of this next one?
13.
13 plus.
Okay.
13 plus.
13 plus 13 or minus 13?
Plus
Plus.
13.
Plus 13. Plus 13.
Good.
Minus 4.
Okay. What about the next one?
-4.
Yeah, good. The next one?
17.
17.
18.
17.
18.
17.
Yeah.
Yeah,
It is
17.
like 28 minus 11, right? Yeah. The next one?
Minus 10.
-10.
-10.
Are you sure? Okay.
-36.
Okay. What about the last one?
You cannot see.
So we cannot see the last one.
Okay, let me write that then. -3 minus of -7 minus 5.
Minus 3 plus 7.
Sir, it's minus plus 5.
Sorry, I didn't get you.
Plus 4 minus 1.
-1.
Okay, can you tell me how you got -1?
So 7.
Minus 3 plus 7
-3 plus 7
is equal to 4.
is equal to 4. Then
4 minus 5.
4 minus 5.
Sir, should I say how it's solved?
Sorry?
Should I say how it's solved?
Yes,
Should I-
please. Yes, please.
So, as it's -3 minus -7, so it's
Okay.
-3 plus 7 minus 5.
Yeah, so it becomes a -3 plus 7, isn't it?
-5, yeah.
Yeah.
And then you can do either -3 plus 7 or plus 7 minus 5. So
Excellent.
plus,
Let's try this, okay? This is associative property, isn't it?
Mhm.
Yeah.
So it's -3 plus 2,
Okay.
which is -1.
Excellent. Very good.
Thank you, sir.
Okay, so I think let's try the multiplication, at least first couple.
So can I say the answer?
Yes,
Minus 54.
very good. What about the next one?
15.
15.
Good,
Minus 28.
nice,
49.
very good.
Minus
8.
8 minus 8.
The
Minus.
last one,
Oh, last one.
30.
30. Plus 30 or
minus 30. Minus 30.
Minus 30.
30
Plus
Would like to know the reason.
30 plus 30 plus
It's 30, sir. It's 30.
So,
So
two
there's
times,
plus and there's
Yeah.
plus and minus, so minus 30.
let me explain. Minus 2 times plus 5.
10 plus 10 minus 10.
Hello.
It's positive 10, sir. Because
Yeah.
5 is a bigger number than minus 2, so it's positive 10.
Yeah, minus 10 times minus 3,
Yes,
which
yeah.
is positive 30.
30.
Yeah, please read the question and tell me the answer.
So it's B.
Why and which property we used there?
B.
Which property? Yeah, B is the correct answer. Which
So
property
associative property.
Associative.
for
Ow!
associative property for addition? Okay, we have to see the full name. Got
Yes,
it?
sir.
Yeah. So what about the next number?
It will be 7.
7.
So which property we used here?
Associative property for addition.
Excellent, excellent. So let's try the next two. What about this one?
8.
Sir, it's B.
It's B.
8.
Uh, what property? Can you please tell me the property?
Associative.
Can anyone please tell?
Associative property
Associative.
for multiplication.
Excellent. We have to say that. Yeah, multiplication. The last one, I mean the next one.
B.
C.
C.
Okay. The reason?
Property for multiplication.
Associative
Property for
Property.
multiplication.
Yes.
Agree.
Okay. That's nice. Anyone wants to try this? Which of the
No.
following?
It's not typical grade 7.
It's grade 7.
Yeah, I think it's grade 7.
Sir, it's
Sorry?
B.
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 Okay. No, B is not the correct answer.
Oh, yeah.
C.
So no. Which of the following? Please read the question carefully.
Which
Which of-
restricts the associative law of addition?
What is associative law? The numbers has to be
So A.
same.
I think. Sir,
No.
Sir,
Numbers
none.
has to be same.
Is it D? D?
B.
sir, none.
No. B is the correct answer. I think someone said B, right?
Yeah.
Yes, sir.
Yeah, I said.
Okay. What about multiplication? The second one? Associative law of multiplication. The numbers have to be same, but
So
you
C.
just need to change the bracket.
Is it B? Is it B?
C.
It is C.
So C.
Yeah, you are right. Good. Okay, so I think I have a last set of questions. I think these questions are easier anyway.
16. D.
Yeah. Associative property for addition. And the last question is associative property for addition. Again, we'll get the answer is 6. Yeah. So anyone interested to answer this?
Sir, can I see the first answer?
Yeah.
Sir, the reciprocal of 12 is 1 by 12
सुन ले
Very good.
because fraction of 12 is 12 by 1 and reciprocal of 12 by 1 is 1 by 12.
Excellent. Excellent. What about the next one?
16 by 5.
What about the next one?
16 by 5.
16 by 5.
Yeah. Just a reverse. You just need to flip the fraction. That's it.
So next one.
4 by 3.
Excellent. You're right.
Three.
I think I already answered the question. So is there any other way to answer that? Is it the correct answer? Is it simplified
Yes.
answer?
Yes.
By
Is it simplified answer? The question is. So
That's
generally we write the negative sign in a numerator or in front of a fraction, right?
yeah.
Yeah. So we can write this as a minus of 1 by 8. Got it?
Yes.
Yeah. So no need to try the next one though. Yeah, that's
So
it.
actually that is additive inverse is plus 5.
Yeah, plus 5. That's good. Okay. So I think that's it of this class. Do you have any questions? Anyone?
No, sir.
No, sir. Thank you.
Thank you.
Okay.
Sir, is it okay if we can leave now?
Yeah. Then take care. Then if you don't have any questions, please go ahead and take care. Thank you.
Okay. Thank you.
Bye.
So the class is done.
Yeah. Bye. Take care.
Thank you, sir.